Welcome back to Differential Calculus. In this video, we are going to be talking about indeterminate form. You may or may not have come across the phrase indeterminate form in a previous mathematics course. It describes some of the interesting things that happen around the number zero with multiplication and division. Let me get my head out of the way and let's go back to the basics. We know that division was originally defined as the inverse of multiplication. If A times B is equal to C, that is equivalent to saying that A is C divided by B, or B is C divided by A, but let's just stick with this one. When we say that taking 0 times some number gives us 0, equivalently, we say that 0 is what we get if we take 0 and divide by some number. And then there's where the problems start. If it was possible to get something A times 0 equals C, well, we know that that works when C is equal to 0, but for anything else, this is giving me that A is C divided by 0. And we know that this is, well, nonsense. That is why dividing by 0 is undefined. C divided by 0 is undefined when we have that C is not equal to 0. Here's where I said it gets a little bit interesting. Because if I go ahead and accept that, yeah, A multiplied by 0 is equal to 0, turning that into a division problem would tell me that A is 0 divided by 0. And we learned the rule in arithmetic that dividing by 0 is bad, and we never divide by 0, and dividing by 0 gives us nonsense. But the statement of the expression here as a multiplication problem, that makes perfect sense. If you take any number and you multiply by 0, you are going to get out 0. And so that's where this division problem becomes nonsense. Because you can make a case for any number A to show up here, and it would be equally valid. That's a problem, right? You can't have any number show up when you perform a computation. It has to be deterministic. There has to be a single value that comes out of an operation. Otherwise, math kind of falls apart. 0 divided by 0 does not have that. So 0 divided by 0 doesn't work for a very different reason than anything else divided by 0 not working. 0 divided by 0, instead of being undefined, is called indeterminate. Depending on the situation, when you have 0 divided by 0, it might be that you can work backwards and figure out what you were supposed to have. Thinking about this from a different approach. You were taught in basic algebra that you can multiply or divide anything on both sides of an equation and the equation is still true. You just should never multiply or divide by zero. Never dividing by zero makes sense. We just talked about all the problems with dividing by zero. Never multiplying by zero, at first glance, well, yeah, you can. If you take any equation and you multiply both sides of the equation by zero, you get 0 is equal to 0, which is absolutely true. The problem is if you started with an equation that is sometimes true and sometimes false, you lost information by doing that operation. Dealing with indeterminate forms, working with calculus and with limits, our goal is to, in a sense, look at that situation where you just lost information and try to figure out if that information is recoverable in some way or another. And so when we're looking at a limit and we have an indeterminate form show up, we are going to take it as a sign to do more work. So for example, the limit as x approaches 0 of x squared plus 3x over x squared minus 5x. If you try plugging in x equals 0, you get 0 over 0. Which we just said was our indeterminate form. And when we have an indeterminate form, we cross our fingers and hope that something good will come out of it. Sometimes it will, sometimes it won't. Only one way to find out. And so we go back to our fraction and we factor the numerator and denominator. And crossing out the x, top and bottom here, does subtly change the function. Let's use red. I usually use red for crossing things out. It does subtly change the function, but it doesn't change it away from 0. When x is equal to 0, this makes a difference. When x is anything else, it does not. And because we are taking a limit, and for some reason I have a bar in the middle of my limit, let's get rid of that. When we're taking a limit, we don't have to worry about that. And we can just continue onward and take the limit as x approaches 0 of x plus 3 over x minus 5, which is just negative 3/5. And so our indeterminate form in this particular instance resolved and became negative 3/5. Of course, that doesn't have to happen. If I want to take the limit as x approaches, say, 1 of x minus 1 over x squared minus 2x plus 1. Once again, if I plug in x equals 1 in the numerator, I get 1 minus 1, which is 0. If I plug in x equals 1 in the denominator, I get 1 minus 2 plus 1, which is 0. This is, again, an indeterminate form. And when we have an indeterminate form, it tells us to do more. And so we factor the numerator, we factor the denominator. In this particular case, the numerator doesn't really factor. But that denominator is x minus 1 squared. So one of the factors of x minus 1 in the denominator cancels out the factor of x minus 1 in the numerator, and this becomes 1 over x minus 1 and now we end up with, when we plug in x equals 1, we get an undefined value. And now This is no longer an indeterminate form. This is definitely a problem point on the function. We can conclude that this limit does not exist. I mentioned this briefly in a previous video, but I want to reiterate it here. We never say that a limit is undefined. A limit is defined to exist or is defined to not exist. Limits not existing is an interesting case. Whenever the function itself comes out as undefined, that means that the limit does not exist. Whenever the function comes out as indeterminate, we have work to do. Whenever the function comes out with a particular value, then we're happy and we have nothing else to do. So a limit can have a value. A limit can not exist if it doesn't have a value. A limit is never undefined. A function, an expression, can have a finite value. It can be indeterminate, or it can be undefined, which we will look at more carefully in a future lesson and define that to be an infinite value in many but not all cases. So a couple of things to look forward to. For now, there's not a whole lot going on here, but it's a little bit mind-bendy. So I want to just stick with a very focused lesson in this video. We'll end with one more like this for you to try. So I would like you to evaluate the limit as x approaches -3 of x squared plus 4x plus 3 over x squared minus 9. Take a couple of minutes, see what you can do with that one, and I'll see you in the next video.